So pretty much what we're going to be doing today, tomorrow, pretty much the rest of it, we're going to talk about how to factor tricky stuff. All right, so let's review factoring easy stuff. So what I mean by factoring easy stuff is if I give you x squared minus x minus 6. That's easy to factor, right? It's a quadratic, it's quadratic, and how you factor quadratics is we do two sets of parentheses, and it's nothing to it. It's x minus 3x plus 2, and we're done, right? That's easy, right? But what if I gave you something that looked like, what if I gave you x to the fourth minus x squared minus 6? Is this quadratic? No, it's not quadratic. See, quadratic is degree 2. This is degree 4, so it's clearly not quadratic, right? But you can factor this the same way you factor this, right? So you put two sets of parentheses, and you kind of ask yourself the same questions. You think, what times what gives you x to the fourth? X squared. What times what gives you a negative 6? Well, minus 3 plus 2. And when you multiply it out, minus 3x squared plus 2x squared gives you the negative x squared, and so we factored. In fact, so the level of difficulty of this problem was virtually the same as this, isn't it? We did the same thing. Okay. Well, what if I gave you x to the 6th minus x cubed minus 6?
It's the same thing?
It's the same thing, right? It's the same thing. We're going to go through, we're going to do two sets of parentheses, and you think, well, what times what gives you x to the 6th? Now, you do have to be, granted, there's lots of ways. You can say like x to the 5th, x to the 1st, x squared, x to the 4th. You need to make sure they're the same. So, you need to make sure your powers of x are the same, and so that's going to give me x cubed, and that gives me x cubed. And then, let's see, we'll still do our plus 2 and our minus 3. And when we multiply it out, right, reach your negative 3. This gives me the first term, this gives me the last term. I get negative 3x cubed and a positive 2x cubed, which gives me the proper middle term. Right? So, I should have erased that. This is something called quadratic form. See, quadratic form is when you can still factor it like you still treat it like a quadratic, but it's not a quadratic. Well, if I gave you this, what if I gave you this one? Give you x to the 8th minus x minus 6. Is this in quadratic form?
No.
No. So, one of the patterns to make sure something's in quadratic form, there's a relationship between these exponents. Right? What's the relationship between these exponents?
Common exponent of 3? Multiples of 3?
Half. This is half of this one. All right? So if this needed to be in quadratic form, what must this exponent be?
4.
Does everybody understand that this would need to be this would need to be x to the 4th?
Yes.
And now this is of quadratic form, meaning I get to treat it just like a regular quadratic. I get to say, oh, this is going to be x to the 4th minus 3 plus 2. Do you see when I multiply this out, I get what I wanted?
Yes.
All right? So, your turn. What if I gave you 6x to the 12 plus x to the 6th minus 15? So when I see this, does this look like it's in quadratic form?
Yes.
Right? How do we know? Well, you see, this exponent's half of you have this exponent, you double it here, and then there's a constant, right? So when I look at this, what my brain actually sees is 6x squared plus x minus 15, right? That's how I look at this. Because I say, oh, it's just like this quadratic. So when I factor, I've got to figure out, well, what gives me the 6x to the 12? How are we going to break up the 6?
You can break it into
You can do 6 and 1, but it's probably 2 and 3.
Yeah.
So I'm going to say 2x to the 6 and 3x to the 6. How are you going to break up the 15?
5 and 3?
5 and 3. Can I put the 3 here?
No.
No, right? Because I could factor something out, right? So I know the 3 has to go here and the 5 has to go here. It's a negative 15, and I know one's positive, one's negative. I'm not real sure, so I'll just guess. And when I guess, now I just have to check to see if my middle term works out. And so when I middle term out, okay, that gives me a 9x to the 6th. That gives me a negative 10x to the 6th. That gives me negative x to the 6th. Great, I got the right number, but the wrong sign. That's easy enough to fix. Just make that a plus and make that a minus. Okay? And so I factored. All right. So there are a few methods of factoring we're going to talk about today. So this is called factoring when it's of quadratic form. Like if you treat it just like a quadratic. Except the powers can be a lot bigger. You just have to make sure you have that pattern. In fact, the instructions that you're going to have today, tomorrow, kind of for the next couple of weeks, are going to be factor completely. Okay? Right? That's your instructions. Factor completely. Your job is whatever I give you, you're going to try to factor it. Right? Your job is to factor it. And some are going to be easier than others. So, try this one. X to the 4th minus 13x squared plus 36. Factor. So, is this of quadratic form?
Yes.
Yeah, right? Because you take this, half of it, and the number, right? So it's of quadratic form, great. So I'm going to put my 2 sets of parentheses, and I get x squared, and I get x squared. And you think, well, how do I get the 36? 9 and 4. You could do 6 and 6, but that's not going to give me the 13, is it?
No.
So I got to do minus 9 and minus 4, right? And if I said factor, you factored, yay. But I didn't say factor. I said factor completely. See, that factor completely means just because you factored doesn't mean you're done.
Looks like I did.
Does this factor?
Yeah, it does. It's x plus 3x.
Do you see where you recognize your difference of squares? And so this is going to factor as x plus 3, x minus 3, and what's this one going to do?
X plus 2, x minus 2.
X plus 2, x minus 2, right? Yeah, see, you have to pay attention whenever I say factor completely, and I'll just go ahead and tell you, I am going to say factor completely. Anytime you can factor, you have to keep factoring. So just because you do one thing doesn't mean you're done. So how do we feel about quadratic form?
Great.
All right? We recognize it's a quadratic, and then, maybe not quadratic, but it's of quadratic form, so you get to treat it. You do your 2 sets of parentheses and keep track of the exponent. All right. Next up. We're going to do x cubed plus 3x squared plus 2x plus 6. Write that down. All right, is this a quadratic form?
Yes.
No, it's not.
No.
Oh.
The quadratic form, for the most part, just has 3 terms, doesn't it? Right? This doesn't have 3 terms. There's more stuff going on here, right?
Okay.
So how do you factor this? Well, what you're going to do, and I've kind of found out from the first couple of periods that you may not have seen this. I want you to put parentheses around the first 2 things and parentheses around the last 2 things.
Okay.
All right? Now, when I look at this, is there anything in common in this first group?
No, except for x squared.
An x squared? Everybody see there's an x squared in common?
Yes.
All right, so I'm going to pull the x squared, and then what's left inside?
X and then 3x. Or sorry, an x and then 3.
An x plus 3, right? What's in common here?
2.
So I'm going to pull a 2 out, plus 2. What's left inside?
X plus 3.
X plus 3.
Yo.
All right. Now, when I look at this, I see I have two terms. I have this term and I have this term. Does everybody see that?
Yes.
And actually, in those two terms, you see they have an x plus 3 in common?
Yes.
And since I have an x plus 3 in common, I'm going to factor out that x plus 3.
Okay.
And so when I factor out that x plus 3, what's left inside?
Then it's x squared plus 2.
Everybody see if I pull this out, I'm left with an x squared plus 2?
Yes.
Okay. That's x squared plus 2. And I mean, I use brackets because that's how I was taught and that's how I think about it. If you were to look at the answer in the back of the book, they'd say this is x plus 3 times x squared plus 2. This is called factoring by grouping. And the reason it's called factoring by grouping is math people aren't really creative. We're factoring, right? Because anytime you start with something that looks like this and end up with things in parentheses, you factor. And the reason it's called factoring by grouping is you group these things together and you group these things together. They're not really creative when we come up with names. Yes?
Does it matter like what order?
No. Yeah. This is the way, like, did you have x squared plus 2 times x plus 3?
Yeah.
Yeah, so you were taught that way.
Mhm.
Yeah. I was taught this way, so this is the way I present it. There's nothing wrong with it. The order doesn't matter. All right. So write this one down.
Okay.
So this is a factoring by grouping problem, but I need to talk about the most common first mistake people make when doing factoring by grouping. So if you approach this problem the exact same way we did this problem, you might be tempted to put parentheses here and here.
How do you know I did that?
No.
Okay.
no.
Minus has to be.
Okay. I told you this is the common first mistake, right?
Yeah, that's the minus.
Okay. So I want to talk about why this doesn't work. All right? So in this problem, when I put parentheses here, I did not change the question at all. Because like if I gave you this problem with parentheses in Algebra 1, you say, well, there's nothing to do, right? There's nothing to distribute. I end up with the same thing. If I put parentheses around these first two things, I haven't changed the problem. But when I put parentheses here, what does that negative do?
Distribute.
Do you see how that negative distributes?
Yeah.
And if that negative distributes, that changes the original problem, doesn't it? All right? So, the most common first mistake whenever you're doing factoring by grouping is when you have a minus, putting the parentheses here, you have to be careful because that changes the problem. So here's my solution. My solution is anytime there's a minus sign, what I do is I put parentheses in front of the minus sign.
Awesome. Great.
Okay? Now we're going to approach this the same way we approached here. We look at the first thing, we ask what's in common?
X squared. That's just x squared.
An x squared. Okay? What's left? What, 2x minus 5?
Yep.
And now we're going to look at this thing and we're going to say what's in common? What can you pull out?
Negative 4.
I'm going to pull out a negative 4. And when I pull out a minus 4,
You get a 2x.
I get a 2x minus 5. So when you have these factoring by grouping problems, right, for them to work at all, these things have to be the same, right? See, back in this problem, these were the same. That's how it was able to work. These are the same, so I could pull the x plus 3 out. If you have a 2x minus 5, these things have to be the same. Why am I talking about this? The reason I'm talking about it is, let's say you're doing a factoring by grouping problem, and you see a 2x minus 5 here, and then you did something, you got a 2x plus 5.
Then you.
Those aren't the same, right? That's a big clue that you may have lost a minus sign, because these have to be the same. If these terms aren't the same, you can't do the factoring by grouping. right? And so now when I look at this, what's in common?
X squared minus, oh, sorry, 2x
2x
minus
minus
5.
5.
2x minus 5. So I pull the 2x minus 5 out. And what's left inside?
X squared minus 4.
No.
Am I done?
No, you have to complete that. Like, you have to make that the difference.
Remember, still factor completely, isn't it?
Yeah.
I got a difference of squares. And so that's going to give me an x plus 2, x minus 2, and then end up with 2x minus 5. Now, most Algebra 2 books, as far as factoring by grouping, they give problems like this. That's what most Algebra 2 books do.
I like these problems.
Yeah, I always like factoring by grouping. I felt like I was doing something, right? And unfortunately, your textbook is not like most textbooks. They give a problem like this, but they also give a problem that looks like this.
Just leave.
There's a spot outside.
Yeah, that was funny.
Thank you.
See ya.
Jojo.
Minus 5a.
Yeah.
Oh, what the heck? You freaking wizard.
So your textbook, gives you problems that look like this. So what do? Well, we're going to do this by factoring by grouping. You think, well, how do you group these things? I mean, you could group it like group these, right? And try to come up with something. But whenever something is this ugly, we're still going to group in two things. Right? We're going to do two groups. And so our two groups are going to look like this. We're going to group the first three.
And the last three.
And the last thing, since there's a minus sign, all right, anytime there's a minus, we're going to do this.
Yay.
All right? Now, when I look at this, what's in common? We're okay at 6x?
Yes.
Everybody okay? So there's a 6x in common, so I'm going to pull the 6x out.
Wait, can it be minus 6x?
No.
I don't want a negative if I don't have to. I'll factor out a negative over here, but I don't want the negative here. So what's left?
5a minus 4b plus c.
Wow, wow.
Well, if
I
I pull
wrote it
this,
down. I wrote it down.
so if I pull the 6, that makes that a 5. The x is gone, so I get an a. I get a 4, and then a b,
And a C.
and then I get a plus c. What's in common here?
Oh, wait.
A negative y squared.
Yeah, negative.
Because there's a minus here, we're going to factor out a negative, and then there's a y squared in all those. So I'll pull out a minus y squared. And what's left?
It's the same thing.
Negative, no.
It's the same thing.
No, it's not.
It's the same thing.
Oh, wait.
No, that's a negative C.
It's
Yeah.
Oh, wait, you put the negative
It's the
out.
same thing.
Okay, Drew, I don't need the sass.
I wasn't talking to you.
Okay.
And if you ever question if you factored out properly, remember this times this should equal this times this should equal this, and this times this should equal this.
Okay.
Yay.
And now when I look at it, you see these two, even though they're ugly, are the same term, right?
Yes.
And so I can factor out 5a minus 4b plus c. And what's left inside?
6x minus y squared.
6x minus y squared. So, this looks pretty intimidating, doesn't it?
Yeah.
But didn't we do the exact same thing?
Yeah.
I mean, the trick was we just put parentheses around the first part, parentheses around the last part. You do have to be careful that anytime you have a negative sign, make sure you put the parentheses in front of the minus sign so you don't change the problem.
Do we need to factor out the 6x?
No, it's
No,
not.
that can't be factored. It's not a difference of squares. That's a square, but that's not.
They have to both be square.
Don't be so silly.
All right. Next up. So I need to refresh your memory on something I talked about a month ago. And that thing was, let's see. Remember a difference of cubes?
Oh, yes. Yes.
Okay. So actually, you don't have to actually remember how to do it. You remember that we talked about it.
Yes.
Yes.
Okay.
I think it was on a Tuesday.
Yeah, I think it was a Tuesday. May have been. So how difference of cubes, how that factors is a difference of cubes is going to factor as a two-part thing and a three-part thing. So here's my two-part thing, here's my three-part thing.
Okay.
Now the two-part thing's easy. See, the two-part thing is drop the cubes. So if I drop the cubes, what's going to go here?
X minus one.
And x minus y. Now the three-part thing, here's how you get the three-part. You take this and square it, stick it here. So what's going to go
X
there?
squared.
X squared plus X two.
This thing is this thing squared. So what goes there?
Y squared.
Y squared.
And you put the middle term.
And your middle term is you multiply these together. So when I multiply those together, what do I get? Don't worry about the sign.
Oh,
Just
that's
XY. Now, I do want to talk about the signs. In the signs, I talked about this thing. So,
We did?
Okay, so.
same opposite, always positive. And what that refers to is this sign. This sign is the same as this sign, so it's minus. This sign is opposite of this one, so what's that going to be?
Plus.
Plus, and the last is always positive.
I need to write this down. Yeah.
Okay? So this is a difference of cubes.
Weird.
Well, let's also talk about the sum of cubes. So let's do x cubed plus y cubed.
The opposite. So X squared minus Y squared. X squared minus XY.
And how we factor a sum of cubes is still going to factor. It's going to factor as a two-part thing and a three-part thing.
And that's X plus Y.
So if we drop the cubes, what's going to go here?
X plus Y.
X plus y. And to figure out the three-part thing, we take this thing and square it. So what's going to go here?
X squared
X squared.
minus XY.
To figure this part, square this. What goes here?
Minus XY.
Y squared.
What's that?
And to get this term, we're going to multiply these together.
XY.
xy. As far as our signs go, these signs are the same. This is opposite, so what's that going to be?
Minus.
Minus.
And that's the.
And the last is always positive. So these are the little formulas. Okay? And I talked about this part. So since I'm talking about sum and difference of cubes, I need to refresh your memory on what I expect you to know. Like, I expect everyone in here to know that 16 is a perfect square, 25 is a perfect square, 36 is a perfect square, right? I don't think that's unreasonable at all, right? You should know your perfect squares up to a certain amount. I also expect you to know perfect cubes
Yes.
up to a certain amount. As far as perfect cubes go,
27.
I expect you to know that 8 is a perfect cube.
Okay.
I expect, because that's 2 times 2 times 2, that's 2 cubed. I expect you to know that 27 is a perfect cube, that's 3 cubed.
64.
64 is a perfect cube. 125 is a perfect cube.
This is funny.
Oh, everybody in here knows that, right?
Yep.
Because 5 quarters is $1.25, right?
Two.
I was kidding.
Okay.
I was kidding.
Two.
I expect this. Okay, it's nice to know that 6 cubed is 216.
Yeah.
7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000.
Yeah.
Right? It's very. You need to know. I expect everybody to know up through 125. After that, these are numbers that are going to show up. Your life's going to be easier if you recognize them. All right. So, what do problems look like? Well, let's say I give you 16x to the fourth plus 54x y cubed.
Factor?
Factor completely.
Okay.
See, there's a difference between factor and factor completely.
Okay.
So has everybody written it down?
Yes.
Okay. So, how do we factor? Well, the first thing you always do in factoring, you ask yourself what's in common. What can I factor out?
2x?
Those are 2, right?
Yeah.
And there's an x in both terms, right?
Yes.
So I can factor out a 2x. Oh, wait. What's left inside?
8x to the third and then 27y squared.
And x to the third plus 27y cubed. Does everybody see that?
Like, okay. I wrote it
Right.
down.
Does everybody see this?
Yes.
Now, this is a sum of cubes, right? Like I expect everybody to look at this and say, well, I see the x cube and the y cube, so that part's obvious, right?
Mm-hmm.
But I also expect you to say, oh, 8 is 2 cubed and 27 is 3 cubed. Right? Those are our perfect cubes that I expect you to know. And I want to actually go one step further. What I actually see in this is I see this is 2 cubed x cubed plus 3 cubed y cubed. That's what I see. And the reason I see that is that's going to help me factor this. Because this is a sum of cubes. Right? And the way to factor a sum of cubes, it's going to factor as a 2-part thing and a 3-part thing. The 2-part thing's easy. Drop the cubes. If I drop the cubes, what's going to go here?
2x plus
8x
y.
No, you drop the cubes.
2x
Those
plus 3y.
cubes.
2x plus 3y.
No.
Oh, that.
All the cubes.
Oh,
2x plus 3y.
2x plus 3y.
Yes.
Does everybody see that? If I drop all of those cubes, I get, so this is going to give me 2x plus 3y. Now, let's compute the 3-part thing. Does everybody see how I got the 2-part thing?
Yes.
I dropped the cubes. Now let's get the 3-part thing. How we get the 3-part thing? This term is this thing squared. Square both of them. If I square both of them, what do I get?
4x squared.
4x squared. To get this thing, I square this.
This
9y squared. Does everybody see how we got the first term and the last term?
Yes.
How we get the middle term is we multiply these together.
Okay.
6x.
2x y.
Are we okay with 6xy?
Yes.
Oh, no. Yes.
So when I multiply these together, that's going to give me 6xy.
Yeah.
Now we need the symbols. We need the signs.
Same
Minus
as
plus.
those.
Same, opposite, always positive. So what goes here?
Minus
Minus
and then a plus.
and a plus. Oh, remember that 2x we took out earlier?
Yeah, you have to
It's
put
still
that.
here.
Nice.
Okay? And whenever you do a sum or difference of cubes, I know this looks like some quadratic you can factor. You can't. So don't try.
Okay.
All right, everybody get this one?
Yes.
All right? Let's try it again.
Okay.
Let's do negative 54 minus.
Is that an O or 250?
250.
Oh.
Yes.
Can I like the restroom?
Yes.
Can we just factor it?
It's over
together?
those.
Okay.
Why do people dash these?
But what?
Why do people
So that they don't look like this.
Oh, so they don't look like twos?
Oh.
Because my handwriting's awful.
Hey, I don't.
I need something to make it.
Hey.
Because if I draw a 2 and a Z, that's a problem, right? The same thing happens. That's why people, when they do a 7, they'll draw the dash. For me, when I was in ninth grade, my x's looked like this and my y's looked like this. That's a problem.
That is a problem.
Okay, it gets a real problem in algebra because you got x's and y's all over the place, right? In 10th grade, I realized maybe my x's are fine, but maybe I should write my y's this way. Not that these are neat, but at least they look different.
Yay.
Mr. Albert, this is kind of a random question. Do you like Star Wars?
Yeah, I'm all science fiction stuff. Yeah.
All right.
Yeah. All right, wait, I want to finish this before.
Okay.
All right. So what's in common?
That would be negative 2, sorry, negative 2W.
We okay with the negative 2w? So I'm going to factor out a negative 2w. When I factor out that negative 2w, what's left?
27 plus 125.
Did you watch?
I did.
27 w cubed
Wait, 27W cubed.
plus 125 z to the 6.
Yes.
All right?
Yes.
Oh, look, I have a sum of cubes.
Wow. Crazy how that
Yeah.
works out.
Yeah. So it's a sum of cubes, so I'll have a 2-part thing and a 3-part thing. So let's drop the cubes. What's going to go here?
What is it? 3W.
Okay, everybody okay with 3w?
Yes.
Okay. So that's going to give me a 3w and a plus. What's going to go here?
5Z to the second. Second.
5z to the second.
Drew, can you give us a chance, please?
I was talking the same
Okay.
speed.
Everybody understand why that was z squared?
Yeah.
Because if I cube this, like if I take z squared cubed, that gives me z to the 6.
Okay.
So that's the hard part. Once you get here, the rest is easy. Because this term is this thing squared. And so when I square this, what do I get?
9W squared.
6, no, wait.
Square it. Square the 3.
Nine.
9.
Square.
Okay.
Good try.
So that's going to give me 9w squared.
That's 6.
25Z.
25z to the 4th. Right? Square this. That's going to give me 25z to the 4th. My middle term,
Z squared.
15 wz squared. And now we need the signs. This is the same. This is opposite, so what goes here?
Minus.
Minus. And that's always positive.
Plus. Yay.
Yeah.
Yay!
Oh, wait, we forgot the minus 2w.
Minus
I did it. I
2W
read it on
times
my-
3W
I did.
plus 5Z squared times 9